This is the second video in the Land Use, Land Cover series. So we ended here where we were going to start looking at some examples of land use and land cover. So in your lab, I'm going to ask you to look at these particular images and use the land use, land cover classification system that I provide in a handout to identify what's going on here. And you've seen this image before, so you already know what's going on here, but I'm going to have you assign numbers to this area and maybe this area, right? Different areas. And then this image, I believe, is a new image. You haven't seen it, but I think between using your recognition elements and your general knowledge of landscapes, I think you can also classify this one. Okay. This next one is kind of a fun one. This one, you're going to be using pattern is a big part of the recognition elements here, identifying what's going on. Pattern is a big part of this. I'll give you a hint. These are all individual houses. Okay. So I think you'll be able to identify land use, land cover of that. This one is agricultural land. This happens to be contour cropping in Iowa, where you have to use contours on hillsides to be able to cultivate crops. That one you're not going to be using for the lab. It's just showing you an example. Here's another example. This is an industrial site. So in this one, you know it's industrial because you've got some large buildings, you've got some possibly cooling ponds, you've got these big buildings, but you don't have huge parking lots. You have some parking for workers, but this is an industrial site. Okay. All right, moving on. So there are computer software packages and applications that will do land use and land cover for you. And what you do is you use the spectral signatures, remember talking about that, to tell the computer, well, if it has this spectral signature, then it is cropland and pasture. If it has this spectral signature, then it's a shrub and brush rangeland. If it has this spectral signature, it is water. Then you would use these spectral signatures to help identify. And then there are other sort of equations that can be used. So if the water feature, for example, is linear, it would be classified as a stream. If it's it has a certain dimension to it, it could be automatically classified as a lake. Then you would have to go in and tell it, no, it's actually not a lake, it's a reservoir. So the computer applications can't be perfect, but you can modify things once the computer does its first round of identifying level 1 especially. Level 1 it's pretty good at. So here's a level 1 land cover map done using a computer software package. So you can see red is urban, there's very little urban. Yellow is agriculture. This orange color is rangeland. The green is forest. Blue is water, and there is no tundra. Okay. So one of the software packages you can use is Erdas Imagine. This is pretty much the industry standard for a long time and is a very powerful software package. I've told you about this one before. Erdas Imagine is really good. I had a lot of fun using it and testing it out and playing with it and experimenting in grad school. But this is an example of mapping some forests in an urban area. And there are different types of classifications you can do. We're not going to get into the details if you go to grad school for this sort of thing. You will learn them. Things like per pixel classification, a filtered per pixel, object classifications, all sorts of different methods and mathematical equations that the computer can use to classify. And it can change the way your map looks. So these decisions that you make as the user, on the user end, is really important. Here's a classification map that was created, and here you see it's called a land cover land use map because it is combining the two, land cover and land use, in the key. So you can see that this is dominated by agriculture in this watershed. Here's a land use land cover map of New York State and the surrounding states. What jumps out at you is there's a lot of green, right? There's a lot of forested areas, but then you've got plenty of red and pink representing the urban spaces, and you can very clearly pick out cities like Buffalo and Rochester and Syracuse and Albany, New York City. Long Island is one big low-intensity residential, except for out here. Boston, right? You can pick them out pretty easily. Let's zoom in on New York State by itself. The red is low-intensity residential. The pink is high-intensity residential, so you can see the difference between the boroughs of New York City, some of them, and other parts of Long Island, parts of Staten Island, parts of lower New York State here. And then you've got the different green colors, right? This is herbaceous wetlands. This is evergreen forest, deciduous forest. Trying to see what this sort of lighter green is. Those are not wetlands. The quality of my image here isn't that great, so I think the colors are a little messed up. I'm thinking that's the deciduous, maybe. Anyway, here's one of New Jersey. These are low quality screen captures, so that's why it's hard to decipher the differences, but generally speaking, you get it. Here's some blue. That's commercial and industrial, which we all know New Jersey is very well known for having a lot of commercial and industrial pretty close to New York City. Okay, so let's move to change detection now. Change detection is something that many of you are doing in your research projects, and essentially you are identifying changes in land use and land cover. So you're identifying the changes, and if you had the right tools, you'd be able to map them yourselves. But in many cases, you're finding maps that show the changes, right? You can also use computer applications to show percent change. I'll give you an example of that later. The change detection can be indicators of growth. It can help you predict future land use patterns. There's all sorts of uses for change detection studies. It is more costly than a single image analysis because you need images over a period of time. So you'll need several images, and you need to make sure that they're taken either at the same time of year, the same time of day, the same weather conditions, right? There are certain things that you, depending on what you're detecting the change of, that you'll really have to so let's say you're detecting the change of a glacier and how much it has melted back due to climate change. Well, if you use one image from a winter season and one image from a summer season, it's going to look different even if there was no climate change, because every summer it melts back some and every winter it grows. So that's just a natural change with the weather. So you have to be intelligent about your choices of when the images are taken. Okay. Sometimes seasons don't matter, especially for urban studies of development, right? But you have to think about these things and make informed and intelligent decisions. So with change detection, you're looking at potential changes that you might think are interesting to observe over any specified period of time. There are some general periods of time that you should use depending on what you're looking at, but with a natural disaster, for example, the period of time could be 1 week, right? Because a natural disaster could happen over a couple of days. So it just depends on what you're looking at. Potential things you can create are time series maps. Where you look just like this one. This is a time series map, looking at the same thing over a period of time and how something has changed. You can also create a change, no change map, where you would have specific colors for areas that have changed, and then a specific color, usually a neutral color that doesn't stand out, for unchanged areas, simply showing where there's been change, not necessarily what the change is. And then you can also have a percent change map, which I'm going to show you an example of in a few slides, probably on the next video, just showing the percent of change in a particular area. So how do you describe the change? Well, you have to talk about when and where, over what period of time, where is the change, how much change, was it significant, was it small, how are you measuring how much change, what is the measurement system, what does small mean, what does significant change mean, what does it all mean, what's the context for determining how much change. You have to look at type of changes, such as, is it human or natural? Also with how much change, is it abrupt or is it subtle? So an abrupt change would be like a natural disaster. Subtle change would be, creep and development over a few decades. The type of change, is it human or natural? Why did it change? And are there cycles and trends you can identify? Now, within type of change, what we're going to do is connect land use change with our land use land cover classification system. So, with type of change, is it within the same class? So, for example, you have a level 1 classification and maybe just the percent vegetation cover changed. Or are you going between classes? Are you going from forested to agriculture, right? Which are 2 different level 1 classes. So is there a conversion from one level 1 classification to another? Or are you staying within the same level 1 classification, but just changing the percentage of the cover, or maybe changing the level 2 classification? Maybe it went from, cropland to an orchard, right? So it's still agriculture, but they changed the type of agriculture. So that's something else you can look at in land use change. Okay, I'm going to stop here and we're going to start with the next slide and video number 3.